This is Vacuum 101, Module 2, Vacuum Basics. In this module, we're going to be describing gases as it is significant to understanding vacuum. So the goals for this module is to understand what gas is made of. How do we describe a gas in terms of volume, number, temperature, and pressure? And then we'll get into what defines a vacuum and how you can measure the quality of a vacuum. Let's start with the model of gas, okay? We imagine a gas as a collection of a bunch of molecules, and the molecules are like tiny billiard balls flying around and bouncing off each other or into any surfaces that they run into. I have a simulation that'll demonstrate. In this container, I'm adding some molecules. And just like molecules in our air or atmosphere, they'll bounce off walls and they'll bounce into each other. And not just in this container, but in the air around it, there are a ton of molecules, nitrogen molecules, oxygen molecules, constantly floating around us, even though we probably don't realize it. So what do you need to know in order to describe a gas? Well, some of this is pretty basic. You need to know how much space in terms is occupied by the gas or the volume. You need to know how many molecules there are, the temperature, and the pressure or how hard the molecules hit. Let's look at volume and number first. The volume of the container equals the volume of the gas, and it's labeled capital V, and measured typically in cubic meters or cubic feet. The number of molecules is simply the number of molecules. It's labeled capital N. Temperature is given the capital T, using a thermometer is how you measure it. And it's important to know that temperature measures the average speed of the molecules. The higher the temperature, the faster the molecules. Let me demonstrate. In this container, I've already put in my molecules. And now I'm going to raise the temperature of the container. Notice what happens to the molecules. As the temperature goes up, the molecules increase in speed. Now, when you notice I cool down the container, what happens to the molecules? That's right, they slow down. So temperature has a dramatic effect on gases. How do you measure temperature? Typically, you've heard of Fahrenheit or Celsius, but there's also scales called Kelvin and Rankine that are important, especially as we get into vacuum. Kelvin and Rankine are related to Celsius and Fahrenheit, respectively. It's just a different, they're adjusted, and the scales are set up so that 0 of Kelvin and 0 of Rankine mean that molecules have zero speed. Sometimes it's referred to as absolute zero. But as you could probably guess, it's impossible for molecules to have zero speed. So that's impossible to achieve. But nonetheless, that scale is still used quite frequently. And pressure is another important element in understanding gases. When molecules collide with the surface, they exert force. Pressure basically measures the amount of force per area. So you have here the formula pressure equals force divided by area. Therefore, the more pressure equals molecules hit harder or more often.